So I just wanted to throw together a quick video that would highlight the steps that we took while we were in class on solving quadratics and cubics. Particularly, I want to bring your attention to those where we don't get whole numbers out when we square root. So we'd either get imaginary numbers or possibly need to reduce our square roots. So I'm going to jump into that. We're going to get progressively harder each time. So hopefully this is just here as an extra resource for you. So if you look at this particular problem, you notice that there's two things happening to x. The first thing that would happen to x is that we would be subtracting 3. And the second thing that is happening to that, it would be the squaring. So if I put a number in for x, I would first subtract 3, and then I would square. 2 steps. We're going to undo each of those steps, starting with the step 2, and then undoing step 1 in order. That's what it means to solve for x, or to isolate x. So we're going to start by undoing the square by square rooting each side. So on the left-hand side, we get x minus 3, and on the right-hand side, we get 4. But we could also get another equation, which is x minus 3 equals negative 4. Now that's not coming out because of some random thing, but the reason why is that 4 times 4 gives 16, but also negative 4 times negative 4 also gives 16. Both a positive times a positive and a negative times a negative. So we have to consider both cases. On this side then, of course, x would be 7, and over here we would get negative 1. So 2 solutions that can happen here, because there's 2 ways to square a number and get 16. What happens if we look at one like this? Well, we can see the same kind of steps, subtraction then squaring. So our first step, of course, is going to be to undo the square. So we'll square root this time, but we don't get a whole number for the square root of 20, right? So we have our 2 equations, x minus 1 equals the positive version of the square root of 20, or x minus 1 could also stand for the negative version of the square root of 20. And again, the reason for that is that negative square root of 20 times negative square root of 20, a negative times a negative is a positive. So that would be positive 20. And we could explain this with squares like we did in class if that makes more sense. I'm going to avoid that because I'm going to go quick here. So as we had talked about, the square root of 20 is really 2 square roots kind of put together. So the square root of 4 is 2, and the square root of 5 is a decimal, so I leave it as the square root of 5 so that it would be an exact answer. And then we have x minus 1. So if I wanted to solve for x, add the 1 to the other side. So you have 1 plus 2 square root 5. And I can't combine those kinds of numbers because they're different. And so there's our solution. Over on the other side, we're going to have exactly the same steps. The square root is going to reduce exactly the same, except this time, of course, it would be a negative value. And so I would write 2 square root 5. When I add the 1, the only difference is that I would have x equals 1 plus 2 square root 5. So 2 different answers. Oh, excuse me, as I write that, I'm noticing I made a mistake there. Sorry, let's fix that. 1 minus 2 square root 5. So they should look almost identical, except, again, 1 is positive and 1 is negative, because a negative times a negative is a positive, and a positive times a positive is also a positive. So there's 2 different ways to get a positive number. We have to consider both cases. So what do you do with something that looks like this that initially looks pretty scary? Well, now we can see 3 steps. Subtraction by 4, then squaring, and then the third step is this adding 7. So 3 steps that we have to undo. We start with the last step, which is the adding 7. So the very first step we'll do is to go ahead and subtract 7. So our equation becomes x minus 4 quantity squared equals negative 9. And this is where I should start to get a little worried, because how is it possible that some number times itself and I get a negative 9? That doesn't make any sense. We introduced this concept in class. It's actually an imaginary number that would multiply with itself to get a negative number. we had to create this. And we're going to be talking more about this in a later lesson. But let's take the same exact steps, right? So to undo the square, we're going to square root both sides. And we're just going to go with it, even though it doesn't make a whole lot of sense at the moment. So we have two equations, right? X minus 4 equals the positive version of the square root. Or my other equation would be x minus 4 equals the negative version of that square root. So dealing with that square root is the only thing that's going to be conceptually hard right now. Basically, you should realize that the square root of negative 9 is really two square roots kind of put together. And that's going to happen over here as well. So I'll just jump over, and I'm going to be applying the same steps over there, so I'll go ahead and write those two. The only difference is that the result over in the second equation is a negative number. So we have x minus 4 equals that. And we spoke in class the other day that this square root of negative 1 we are defining as a number called I. So the result over here is 3i, which is an imaginary number. So x minus 4 equals 3i. And to solve for x, I would add 4. So 4 plus 3i. And on the other side, it's pretty much all exactly the same steps, right? We still have our x minus 4. So x minus 4 equals negative 3i. And then when we solve, if we add 4, that's 4 minus, and then we have our 3i. So I know that's going to seem a little funky because this is the first time you've ever seen imaginary numbers, and up until Friday that was considered an absurd question. We'll be actually looking a little deeper into it in our next lesson and talking and reminding ourselves of what imaginary numbers are. For now, you can just think about it. If you have a square root of a negative number, treat it kind of like a positive number. You know how you would do the square root, except you're going to have an I that's next to it at the end. So that's all. Fire away questions if you have them. I'll try to do future videos if you need it, but hopefully that will help get you over the hump. Thanks.